All right, ladies and gentlemen, so this is our lecture notes for week 13, which is all about linear regression, as is your Excel assignment. And so what I'm going to do is I'm going to start with the first lecturette. And so the first part in Aleks that they're going to ask you is they're going to ask you to take this data, and of course they give you the different points. So basically they threw this into a scatter plot, and they want you to sketch the least squares regression line, which basically falls right in the center in between these values. So it says in the scatter plot, sketch an approximation of the least squares regression line for the data. So I'm going to show you on Excel how easy this is, and I would strongly recommend at this point you use Excel or some form of technology, because not using Excel is going to just drive you crazy. So here's what I'm going to do. I'm going to literally highlight the data just like that. And I'm going to go to Insert, and I'm going to go to Scatter Plot and throw in the data. There you go. If you notice, this looks identical to what they gave you in the question. Look at the question. See how they gave you the same, basically the same data sketch, right? Now here's the beauty of this. You have this little plus sign that appears here. When you click on it, you can get the trend line. See the little dotted line that's going straight in between as closely as possible in between all of the data points? That's your least squares regression line. That's what they're asking you to draw in your answer. Now, if you want to know how to actually obtain your least squares regression line, you guys have what you need. You go to data, and let's see here. I'm going to show you how to do this with Excel and with the data analysis tool pack. So I'm going to click on the data analysis tool pack, and I'm going to go down to regression. Okay, and in the Y, I'm going to input all the Y values. So if you notice, those are all the Y's. In the X, see how it says input X range? I'm going to highlight all the X values as well. I did not have any labels, so I'm not going to worry about that. And all we're doing in this case is I just want the data. There's the data. Okay, and here's your least squares regression line. That's what it looks like. Remember, the predicted Y in this case is equal to 11.804. I'm not rounding, so I'm just going to write the whole thing. 80467, in this case, minus 1.01219, and then X. So you're missing the X. And there you go. There's your least squares regression line. That's what they're asking you. If you don't have data analysis tool pack, you can also find the intercept, and you can also find the slope. And we're going to obtain the same number. So look at what I'm going to do. I'm going to go to equals int intercept. It's asking me for the known Y's, comma, known X's, and hit enter. Notice that this number is the same number we obtained here, which is the same number we're using here in this equation at this point right here. Okay, if I want the slope, all I need to do is go into an empty cell and go equals SLOP, double click on the slope. They're asking you for the known Y's again, known Y's, comma, and then known X's. I would not use calculations at this level. Notice that matches, and I'm going to do this one in green. This number matches this number, which is in our equation is this number right here, the negative 1.01. And it is negative. As you can see, left to right, it's going down. So it tells me that there is a negative association between these variables, although very strong. See how tightly knit the points are among the least squares regression line? You notice your correlation coefficient is 0.978, almost 0.98. It's very strong. So we would say we have a negative but a strong correlation or association between the two variables. whatever they represent. Again, this is the square of that number. 0.95 times 0.95 will give you approximately 0.978. Okay, and our significance level is truncated, super truncated. You notice that and you can tell by the tightness of the points around the linear regression line. You see how the points are hugging that linear regression line. This significance level is basically the value 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's what that number looks like. That's what that e to the negative 12 refers to. So we are definitely rejecting a null, and so there is definitely an association between these two variables, whatever they represent. Okay, so in your question, this is what they're asking you. Let me go back to the example so you can see their explanation and of what they want. And so in essence, that's what they want, and that's exactly what we have. Okay, so let me see another, and I don't think it's going to vary much. Same thing. So you have a least squares regression line. They're going to ask you to input the variables. You're going to follow the same directions I just gave you. I'm just going to do a couple more just to see if they changed the process. Now, in essence, it's the same process over and over and over. Okay, so that's the first question that they give you in your homework. Okay, the second question they give you in the homework, they're asking you to identify the type of relationship or association that you have here. So let's look at the first one, the XY pairs. You notice how this looks like just a scatter of random scatter of X's. There's no pattern, no association. This is very close to an R equal to 0 or basically no correlation. If you look at this one on the right hand side, the UV, you notice first of all that it's declining. From left to right, it's going down. So this is a negative association. I would also suggest that this is a negative and moderate to low association. If you look at WT is a perfect +1 association. So R is equal to 1 for this one. It's a perfect association. You notice that these are exactly one after the other And then we have MN. MN is a positive association, but not perfect. Okay, so let's take a look, and let me see if I can actually click on these. So it says, which data set indicates a perfect positive linear relationship between these two variables? Obviously, that's WT. And you literally are going to click on this. It's a drop-down menu, and you're going to select WT. So rather than do that, let me just show you the explanation because I don't have the same functions you do. And so they do give you a nice little explanation. I verbally stated this several times, but if you need to read through this, it might help you. And so here we go to answer Part A. Here's what this looks like. It's a drop-down menu. If you remember, WT was a perfect positive. In other words, look at the diagram. WT, which is this chart on the bottom left, it's straight, perfect positive association. Which data set indicates the strongest negative linear relationship? Strongest negative. Okay, so as far as negative relationships, there's only one. It's the UV. It's not necessarily so super strong, but it is the only one that's present. So it wins. The UV is your answer for that one. For Part B. And then which data set has an apparent negative but not perfect linear relationship? Again, the only one that we have is UV, so we wouldn't bother. And now look at the last one. It says, in which data set is there evidence of a strong nonlinear relationship? That would look like a parabola, usually like a U shape of some sort or an N shape. In this case, not one of them. Okay, let's see if I can pull up another one and we could just talk about it as well, because I can't click on anything. Okay, so make up your minds here. These are both negative, right? The UV and MN on the right-hand side are both negative. There's only one positive. There's no perfect negative. There's no perfect positive. There's no nonlinear. All of these are linear. No parabolas, just a scatter that's random, which means no association. All right, so remember that. The positive is the xy. Positive xy. Now, what I would also make a connection here is, yes, these are both negative, the UV and the MN. But the UV is a little tighter, so it's a stronger association than MN. All right, with that said, let's look at our questions. I'm going to give you a nice little explanation. So notice here they're asking you which one has a correlation coefficient R equal to 1. That's a perfect association. And this will be none of them. None of them are perfect. Which data set indicates the strongest positive linear relationship? We only had the one, which is this one right here, which is the first one, which is XY. That's the only positive one we have, so we would answer XY for that. For which data set is the sample correlation coefficient closest to -1? So closest to -1 means we have a pretty tight association. Now remember, both UV and MN have a negative association. They both drop down left to right. However, remember I stated that UV is a little bit closer packed together, and that would answer that question. It's not perfect, but it definitely is closer to -1. The last one, for which data set is the sample correlation coefficient R closer to 0, meaning no association. And so if you remember on the left-hand side bottom part, you have this cluster WT, and WT is pretty much all over the place. Okay, and let's look at another example. Okay, so which one doesn't seem to have an association? In this case, R is getting close to 0. That would be XY. Okay, perfect positive association would be UV in this case on the right hand side on the top. That's a perfect positive, or R equal to +1. You do have a negative association and you do have a positive association along the bottom. So WT would be a negative association, not perfect, but negative. MN is definitely positive, but not perfect. Okay, so let's go look at the questions. Look at what it says. Which data set has an apparent positive, but not perfect linear relationship? So let's go back to the top. MN at the bottom right hand side is definitely positive but not perfect. UV, however, is perfect. Okay, which data set has an R equal to -1? In other words, which of these has a positive but perfect negative association? I just misspoke. Which one of these has a perfect negative association? Well, none of them. We only have one positive. Perfect. For which data set is the sample correlation coefficient closest to R? In other words, it's scattered, and that would be XY, which is the cluster of randomly assigned X's. And the last one, which data set indicates the strongest negative linear association? So that was the WT, because that's our only one. All right, and that's the gist of this. And again, if you have questions, you can always reach out or read the explanations. They give you lots of good information here. Okay, so as we look at the third type of questions you're going to answer, this one's a little bit more involved. I need you to pay significant attention here to this linear regression line where you have 3.65 plus 0.15x. So they do give you the linear regression line. You don't have to compute it. That's this line right here that I'm pointing to with the cursor. It sits right in between the values, right? So this is what we call observed data, and the chart is where we see observed values. Now, look at number 1, or part A. It says for the data, values for the theater revenue are less than the mean of the value for the theater revenue tend to be paired with values of the rental revenue that are, And when you drop this down, it should be less than, greater than the mean of the values of the rental. In this case, it would be less than, which you can see if you just take a look at the actual x-axis and y-axis relationship between these two. According to the regression equation, for an increase of $1 million in theater revenue, there's a corresponding increase of how many millions of dollars? Well, that's where we look here. We see where the x is sitting, in this case an increase of 0.15. What was the observed rental revenue in millions of dollars when the theater revenue was 24.5? So the theater revenue is 24.5 here. The rental revenue in the observed is 9.0. And when you look at part D, it says, well, how can we predict the value? So in this case, if I plug in the 24.5 in for x and I multiply this, I'll have my solution. So let's look at the explanation so you can see what I'm referring to. So we start with part A. That was a drop-down menu, and I said that was less than. This is the 0.15 we obtained from the linear regression, which is right here. The observed, again, you go back to the chart and look up 24.5, and the observed rental revenue is 9.0 when the theater revenue is 24.5. Again, I went back to the chart for that. So I'm looking at 24.5 on the left-hand column, and I'm pairing it with the 9.0 for rental revenue. And the last question is simply substitution, and so what we want to do is put in the value 24.5 into the equation as shown right here. They do show you that right here. And when you plug that in and do the math, you should get 7.3. And that's what you'll have to do for these types of problems. They're pretty much consistently the same problem over and over. So show you another. So see again, they're showing you player payroll versus attendance. They give you the linear equation where here 5.91 plus 0.34x. And so we're choosing, in this case, for the data, the player payrolls that are less than the mean. The mean, by the way, is where this line sits. So these are paired with, and again, we're checking to see if it's less than, greater than. So in this case, this would be less than the mean attendance values. Now, in terms of increase, decrease for part B, you look at the sign in the equation. You see how that's a plus 0.34? That means increase. If it were a negative 0.34, that's a decrease. So in this case, an increase of 0.34 thousand fans in mean attendance. Now, notice here that these two got interchanged. See how that says, what was the observed mean attendance when the player payroll was 65.4? Let's see, player payroll, 65.4, right here. And you notice that in that case, that's Houston. Player payroll 65.4 means a mean attendance of 31.11. You see that right here. In this column right here, or this row, I'm sorry. This row right here, Houston. All right, go across. And the one above, part C, you're plugging it into the equation. So they're showing you here, they're going to plug in the value into the equation. So you're going to say 5.91 plus 30.34 times 65.4 is 28.15. And that's all. Like I said, this is basically the same question over and over. You just need to focus on the nature of the question. Now this last question, I think I showed you a general example. So let me see if I can copy this example. Notice they're asking you, they're going to ask you a few things here. First of all, they're going to ask you the slope, the intercept. They'll also ask you perhaps about the correlation coefficient. So using this data, I can actually show you how to do this in Excel, just super easy. So you're going to do control copy here. I'm going to grab an Excel sheet. Let me go ahead and grab a clean one. All right, let's use here. Oh, I did that again. Let's copy this guy again. And I'm going to drop it right here. What just happened? Why is it doing this all of a sudden? Okay, that was weird. Let me try that again because I know I was able to do it before. But here, I can show you this with another example. Let's go back to, no. I've done this on another sheet with another example. Let me see where I have it. Okay, let's use this to raw data. I can use the data from our real estate example. So if I want to find the correlation coefficient, and I showed you on Excel how to use this and interpret this. All right, this is the correlation coefficient. I'm going to show you how to find the slope again and how to find the intercept. Okay, and I want you to look at the acronyms here. So you're going to go equals Corel. Double click on Corel. It's going to ask you for array 1. You just want the numbers. Array 1, comma, here's array 2. Hit enter. There's your correlation coefficient. I talked to you about how to interpret that. And in that case, remember, we have a positive and strong association. Because it's a positive, I would expect the slope to also be positive. So notice that I double click on slope. I'm going to use the y's, which in our case was property taxes. And the size, which is in our case the known x's, and hit enter. That's our slope. Notice that it's positive. Intercept, you're going to go equals INTER. There's your intercept. It's asking me for the known y's, which is this, comma, our known x's, which is this. I hit enter. So there you go. And that means that our linear regression equation is predicted y, as we stated earlier, is equal to, you can do 6617.0954. That's our intercept. So that will be plus the 6.782843. You get the idea, and then x. And that's your linear equation. Okay, you obviously want to always open that up so it shows properly. So you can summarize this number if you wish, or if you want to be really, if it doesn't tell you otherwise, you can actually just use all of the numbers. That's how you would do any of the questions they're asking you here for that particular example. All right, I hope this helps you with the homework. Let me know if you have any questions via text, and I'll plan a Zoom session with you.